2 of the quadratics lesson. So we were asked again, find the x-intercepts for the following quadratic functions. So remember, you can have 2, 1, or no x-intercepts. On the first 3 examples we've just been doing on the previous version, there were no x-intercepts, all because you, taking the square root of a negative number, which happened to be the case in all of these 3, ends up with an imaginary solution. So you can say no solution if you want. You can say, to be even more mathematical if you want, you can say no real solution. No real solutions. There are imaginary solutions, but there are no real solutions. So if you want, feel free to add this in because it kind of sounds a little bit more mathematical. There are imaginary solutions because the square root of a negative number is an imaginary or complex number, but there are no real solutions, and our course doesn't deal with imaginary numbers. So no real solutions. Could be what we could write for that, which is our answer, by the way. It's a bit disappointing. And it all turned out the reason why they had no real solutions was because the x-intercept, there was no x-intercepts, as we found by graphing on the TI Inspire. So remember our little TI Inspire here. So let's do some more. So when we graph, they turned out these 3, they have no x-intercepts. Let's see what happens with the next 3. Maybe there'll be some x-intercepts this time. We can only hope. So let's do it by hand. So remember quadratic formula, if you've forgotten it, I'll just write it here. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So a good thing to write out maybe on the side is what is a. It's 1.5x squared, so a equals negative 1.5, sorry. B is, it's negative 1x, so b equals negative 1, c equals 0. Plug it into our delightful little formula. X equals negative b, so positive 1, plus or minus the square root of b squared. Negative 1 times negative 1 is positive 1, minus 4ac. So 4ac is like saying 4 times, negative 1.5 times 0 is like 4 times 0. Over 2a, so negative 3. So x equals 1 plus or minus 1 minus 4 times 0 is square root of 1. Looks like we're going to get an answer this time, which is lovely. So x equals, got 2 solutions, 1 plus the square root of 1 is 1 over 3. We can also get x is 1 minus the square root of 1 over 3. So 1 plus 1 over 3 is 2/3. 1 minus 1 over 3 is 0/3, or 0. So it looks like we have 2 x-intercepts this time. If you want to check it on the TI Inspire, let's do that. Let's get really good at checking our answers. If it was non-calc, we could only really do it that way, that we just did it. But if it's got with calc, you could check on by graphing it. So people will get good marks if they learn how to check their answers quickly by graphing and doing all sorts of tricks on here. So it's negative 1.5, 5x squared minus x. Minus x, have a look and see what I've typed in. Is it right? Yep. Cool, we've got 2 x-intercepts. Remember, we can go menu. We could try tracing. Do you want to trace? Graph trace. So graph trace, go left and right. That's our maximum. That's our. So if you did happen to want to find the maximum, you've got it here. That's negative 1/3. That's what is that? Negative 1/3. 0.167. Assuming that's 0.16666, which is 1/6. I could probably change these to fractions as well, or just leave 3/6 if you want. See, if I've arrowed right until it said 0, arrow left. Arrowed left till it said 0. 0s are where the x-intercepts are. So we've just found our x-intercept. It's at negative 2/3. So why is that? What did I do wrong? Oh, I forgot to divide by negative 3. That's it. Cool. So see how that was a nice little method. I forgot I was dividing by negative 1/3. 1 plus 1 over negative 1/3 overall is negative 2/3. So that was handy that I checked that, or else I would have been left with the wrong answer. So negative 2/3, back to showing you. So negative 2/3 for this one, and then arrow to the other one. Let's confirm that the other 0, x-intercept is at x is 0. That's right. So one's at x equals 0. One of them's at negative 2/3. You've got to arrow till it says 0. Pops up. Brilliant. So we've got the right answer now. Hooray. Next one, let's do this one off. What's our a? It's positive x squared here, so a equals 1, because it's 1x squared. There's no x term, so b equals 0. C is a constant term, negative 11. Let's work it out with our quadratic formula. X equals negative b, got negative 0, which is a 0, plus or minus square root of b squared, 0 squared is 0, minus 4ac. So what's 4 times ac? AC is 1 times negative 11. 4 times negative 11 is negative 44. So negative is going to end up with a plus. 2a is 2. I'm being a little slack. If you're doing it properly, you should be subbing in everything into the quadratic formula properly. But I'm doing this quickly so as not to bore you senseless. So 0 plus or minus square root 0 minus negative 44 gives you plus 44 over 2. So x equals 44 if you simplify the third. 0 plus or minus, would you agree it's 4 times 11? So square root of 4 is 2. So it's 2 root 11 over 2. So we've got two answers. X equals 2 root 11 over 2, because 0 plus 2 root 11 is just 2 root 11. And the other one is 0 minus 2 root 11 over 2. 2 root 11 over 2. Do you agree both of those simplify? Because you can cancel down 2 here, and you can cancel down 2 here. So this one will be square root of 11. This one will be the negative square root of 11. Let's hope I've got it right. That one, and that one. Remember, people check by graphing. I'm going to keep reminding you how to check by graphing because it's so important, so I'm going to bore you by doing it every time. You should be actually manually doing this yourself too. Don't just rely on watching what I'm doing. Oops, there we go. What was our silly equation to begin with? Negative 11 plus x squared. So don't bother rearranging it, just type in exactly what you've got. Negative 11 plus, where's my x squared? Have a look, did I type it right? Negative 11 plus x squared, yeah, I hope so. Go menu, analyze, no, I do. You can do analyze graph and find the 0 manually, or you can just trace and graph trace. Don't mind. So let's keep it tracing. X-intercepts are further up. There it is. That is the square root of 11, and I'll show you soon. Prove it to you. Square root of 11. What's our x value there? 3.3. You just rounded it. What is the square root of 11? Let's double check. That's probably something I should have done first, just so when we're checking, we know we've got the right answer. Oh my, where's the square root? I can't see it. Eyes about. Yep. There you go. Square root of 11. It is that number. So notice the calculator rounded the first one to 3.32. It rounded the second one to 3.3. That's just a weird thing with the rounding. I think square root of 11 is a better answer. So I've got one answer at positive square root of 11, one answer at negative square root of 11. Loveliness. Finding the x-intercepts when you've got this nice factorized form in the next one is so nice. Because remember, at the x-intercept, what is y always equal to? It's always equal to 0. Because at x-intercept, y equals 0. So what I've done is I've just subbed 0 into the factorized form, which means you look at it separately. So x minus 4, you can write it out if you want, x minus 4 equals 0, and x plus 1 equals 0. So you're separately setting each bracket separately equal to 0. So imagine that one's not there. What's x? If x plus 1 equals 0, what's the answer? And then imagine the other one's not there. X minus 4 equals 0. What's the answer? And hopefully you just got the lovely answers. X equals 0 plus 4, x equals 0 minus 1. You can still check it. I'm going to check it. I'm going to be really thorough. I'm not going to let any examiners take any marks off me. So if it was with calculator, of course, I would check it. Let's do graph. Graph. You got to get really good at your graphing. So we can put it in just like this. Don't bother foiling it or anything. Just put it in the way it looks. X minus 4. Close your little bracket. Open up another bracket. X plus 1. Check that I enter it in right. Beauty. So go there, trace, graph trace. Go left till it pops up 0, 0, 0, 0. Yep, there's one at -1. Nice, matches this one. Let's hope the next one's at +4. It looks like it is, but we can be even more thorough by just going here until it goes 0. It's at +4. That's lovely. So please become really good at your graphing. Like, don't just even watch me do it. Like, don't just watch me do it. Make sure to actually manually try it out yourself too, because then you'll remember how to do it then. So that was finding the x-intercepts. What if they instead wanted you with the same functions? Find the equation of the axis of symmetry. So remember the axis of symmetry. Here's your little quadratic. There it is. The axis of symmetry is, what's the equation of the vertical line? Cuts right through the center. And it's got to be an equation. And remember, it's got a little formula, x equals -b/2a. So the equation for finding the axis of symmetry is -b/2a. And because remember, y equals ax² plus bx plus c, so that's where the a and the b come from. So the general form of a quadratic equation is ax² plus bx plus c, and so on. So we just only need to know, we're just going to use the equation of the axis of symmetry formula. This is our little formula we're using here. We're just going to find out what they are. So we only need what a is and b is. A is 3, b is -2. Let's plug it into the formula. X equals -b/2a. -2. Be really thorough maybe. Don't be a corner cutter like I've just been a few times in this long video. -2 is +2. That's 6. So x equals a third. If I just wrote a third, I wouldn't get my mark, because the question's asking what is the equation of the axis of symmetry. So your answer needs to be an equation. So that's it, because remember, equations of vertical lines are in the form of x equals a number. Equations of horizontal lines are in the form of y equals a number. Next one, y equals, what am I saying? Y equals, a equals -1, because it's -1x², b equals +4. Let's plug it all in. X equals -b, -4 over 2 times -1. So x equals -4 over -2. Negative divided by negative is positive. You could check these by graphing. If you graph them, the way to check them is find the x-coordinate of the vertex. So you would do that graph trace that I did beforehand, and you would find the vertex. And I'll show you what I mean, because you're probably thinking, what is she talking about? Let's do one. So the one that was already here, the way I find its vertex, the vertex is down here, because the equation of the axis of symmetry would cut through the vertex. So I would go menu, trace, graph trace, arrow left and right and all that bizzo down to the vertex. What flashes up when you hit it? Let's see. Ah, nothing did. That's great. Sometimes it does, and it says maximum or minimum. Maybe it's because I messed around with this graph already. So if nothing's helping you out, nothing's popping up and going maximum, minimum, look, the y-intercept popped up. But for some reason the maximum, it's a minimum this time because it's down the bottom. You could do it by hand instead. Analyze graph, and it's a minimum. So go left, enter, go right, enter. There, it's kind of like stuff's in the way. There it is. There's the vertex. So 1.5, this is not the graph that I just did, this is another graph. So if I wanted to do the one we just did, let's practice it again. We'd have to enter in y equals -x², -x² plus 4x minus 5 plus 4x minus 5. It's a beautiful graph. So let's see what happens when I trace it. It doesn't have x-intercepts, but it does have a vertex. Graph trace. Let's see this time if it's a maximum, isn't it? Because it's the top. See, look, it told us this time. Perhaps it's just because I was messing around with that other graph too much before. Maximum is at x equals 2. So the axis of symmetry should be the same thing as the coordinates of the vertex. So by the way, if you're asked for the coordinates of the vertex, you can just do it like this. But we want to just know the axis of symmetry, the equation of the axis of symmetry, which happens to be the same as the x-coordinate of the vertex, because it cuts through the vertex, the axis of symmetry does. keep going. A equals, next one, don't be fooled by this, it's 2x squared, so it's not a equals negative 1, a equals 2. B equals a coefficient of x, negative 1. So x equals negative b over 2a, negative 1 over 2a. X equals 1 over 4. Done. Next one. A is negative 1.5. B is negative 1. X equals negative b, negative 1 over 2a, to negative 1.5. X equals 1 over 2 times negative 1.5 is negative 3. That's fine, you could leave it like that, or you could say negative a third. And circle both, because both are fine as your answer. Next one along. It really helps to write out what A is, what B is, otherwise you can plug in the wrong number. Because it's 1x squared, so A is 1. B is 0, because there's no x term. Because negative 11 happens to be the C of the B. So x equals negative b over 2a, is of course 0 over 2, which is 0. So you can have an axis of symmetry that cuts through x is 0. That's totally possible. To find the axis of symmetry of this one, if you're to use x equals negative b over 2a, you're going to need to FOIL first. Let's FOIL everything. Y equals x squared plus x minus 4x minus 4. So y equals x squared, x minus 4x, negative 3x minus 4. So we can now write out a is 1, b equals negative 3. So x equals negative b, negative 3 over 2a. X equals 3 over 2, which is fine, or you could write 1.5. Last one. Okay, no, this is almost. Find the coordinates of the vertex for the following functions. By the way, have I finished this? I'm just going to check. Okay, good. Okay, I've forgotten it. Find the coordinates of the vertex. So the vertex is like the maximum or the minimum. So maximum, max or min. The vertex is like the turning point. So if you want to do a little sketch of a vertex, so you can look back and not forget what it is. This is the vertex. It's the turning point. It's just a mathy word for the turning point of the graph. It could be a maximum, or if it's the other way around like this, then it's a minimum. The bottom. Find the coordinates of the vertex for the following quadratic functions. Recall, the vertex is the turning point of the graph. It can be, as we just said, a maximum or a minimum. You find the coordinates of the vertex by graphing the function on the graphing calculator and pressing menu, analyze graph, maximum or minimum. Remember, you can also just press trace and graph trace. That's another way to do it. But notice that the first time I tried to do that on the previous examples, it didn't work. So if it doesn't work when you just do trace and graph trace, if it doesn't pop up with a maximum or minimum when you're around that area, then instead do it this way. Menu, analyze graph, select maximum or minimum, and then click left and right. Alternatively, if you were to do it by hand, find the axis of symmetry using the equation of the axis of symmetry, and then sub that value back into the original equation to find the y coordinate. I'm going to do it that way to start with. X equals negative b over 2a, and then we sub it back in, just so you can see what I mean by this. Here we go, a is 3, b equals negative 2. So I know we did it on the previous, but let's practice it again. Negative 2 over 2a. X equals positive 2, 6. X equals a third. So we've just found the x coordinate of the vertex. We now need the y coordinate of the vertex. So you want to section it off. The y coordinate will be y equals 3 brackets. So we've got to put in a third. So 1/3. I'm using the green equation above. 3x squared. And we know x is a third, so 3x squared minus 2 times a third, kind of awkward, do by hand this one, and then plus 1. It's a green equation above, subbed in. Now we've got to use BEDMAS. 1/3 times 1/3 is 1/9. 3 times 1/9 is 3/9. 3/9 is the same as 1/3. Minus 2 times 1/3, 2/1 times 1/3 just gives us 2/3 plus 1. So 1/3 minus 2/3, would you agree, is negative 1/3? And plus 1 is like saying plus 3/3, if that helps. So y equals 2/3. So our vertex, don't forget to find your final answer, is 1/3, comma, 2/3. Don't forget to write the vertex as a coordinate. Let's check that by graphing. You might want to pause at this point and just do your own ones for a while, because you're probably getting the hang of it. What is this one again? It's 3x squared minus 2x plus 1. Enter, and we can go menu, analyze graph, and do, it's a minimum in this case because it's the bottom, or we can try trace and graph trace. Sorry, a bit left to begin with. That's a y-intercept, that's not it. Minimum, okay, it did come up. Minimum, it's confirmed for us, it's 1/3, and that's 2/3. So we've got it right. Hooray. I'll do this one by hand too. A equals 3. No, it doesn't. A equals negative 1. 3 equals 4. Let's plug it in. X equals negative b over 2a. So x equals negative 4 over, I did it wrong before. 2a is 2 times 1. 2 times negative 1. So x equals negative 4 over negative 2. X equals positive 2. Done. Now let's find our y coordinate. Y equals negative x squared plus 4 times x minus 5. I'm using the green equation above. Minus 5. So y equals, do BEDMAS first. 2 squared is 4, and the negative of that answer is negative 4. Plus 4 times 2 is 8 minus 5. Negative 4 plus 8 is 4 minus 5. Y equals negative 1. So our answer is, don't forget to put your x first and your y second. Again, check by graphing if you like. Here we go. A equals, that's 2. B equals negative 1. It's negative 1x. So equation of the x's of symmetry, negative negative 1 over 2a. So x equals 1 over 4. Done. Now let's try subbing that into the green equation. Y equals negative x. X is, you can put in 0.25 or a quarter. Practice your fractions if you want. Plus 3 plus 2 x squared. X is a quarter squared. Negative a quarter is just negative a quarter. 3 plus 2. What's a quarter squared? You've got to do BEDMAS, exponents first. A quarter times a quarter is 1/4 times 1/4, which is 1 over 16. 2 times 1 over 16 is 2 over 1 times 1 over 16, which is 2 over 16, which simplifies to 1/8. So if you want to add these together, you probably want to make a common denominator of 8. So equals negative a quarter, negative 2/8. 3 is the same as 24/8 plus 1/8. So equals negative 2 plus 24 is 22 over 8. Put y here if you want, it helps keep you on track. Plus 1/8. So y equals 23/8. So let's write our final vertex. It's a quarter 3 over 8. Hope I got that right. Hope I didn't make a boo-boo. It's the end of the day, so I'm a bit sleepy. So I could do something wrong. We're almost there. Yep, still more. If you want to do these ones by calc, to practice your calc, that maybe is a good idea. In fact, I'm going to do that because I've already given a few examples. I need to make sure you're really good with your calc. So on, here it is, it's negative 1.5 x squared minus x. Enter. And it's a maximum this time because it's at the top. Menu, trace, graph trace, arrow left. Oh, no, it's there. Maximum. Already found it. It's at negative a third, and that's positive 1/6. So if you didn't know, you could just put it to 3 sig figs. TI inspire, negative 1/3, which hopefully matches our axis of symmetry from there. Yeah, it does. Negative 1/3, and when you plug that in, you probably got positive 1/6. What did we? How much was it? Negative 1/6. What is it? Positive 1/6. If you get that, we just plug it in. If you want, you can write it to 3 sig figs. Next one, negative 11 plus x squared. Let's throw that in the calc. Negative 11 plus x squared. Always look back and see, did you type it in correctly before you move on. Like, see that? I just didn't type in x squared, I typed in x2. So it's really important to just have a little look before you press enter. So negative 11 plus x squared. Yep, I agree with what I've done. Vertex is right down here. Menu, trace, graph trace. Good. It's going to be there anyway. Now we want to be at the vertex. No, that's a y-intercept. Maybe it's the same thing as a vertex. I'm not sure. To be on the safe side, I'm going to try the other method, analyze graph, and it's a minimum because it's down the bottom. Arrow to the left, arrow to the right. Yeah, it is. So it's at 0, negative 11 is our vertex. 0, negative 11. So that's why the axis of symmetry on the previous example was at x equals 0. That happens to be where the vertex is. Last one, let's graph it again. I'm really looking forward to this video being over. I can understand. We go brackets, x minus 4, bracket, open bracket, x plus 1. What happens if I don't close the bracket? Yeah, it just closes it for me. That's good. Enter. And it's the menu, trace, graph trace. Pop up. Oh, no, it didn't. It's so funny. I don't know why it doesn't sometimes. So let's do it manually. Menu, analyze graph, and it's a minimum because it's down the bottom. Go left, go right. There it is. Oh, answer somewhere else. 1.5, negative 6.25. Let's check. Is that the same axis of symmetry that we had? Yep, 1.5. Brilliant, so we know that one's right. Just fabulous. So we're almost there. Here's the next one. Now let's try a few exam style questions that happen to mix all of those all together. That last few exercises were quite repetitive. For the graph shown, what are the x-intercepts? So question, here's an example, it's actually filled in for you. Just look at the graph. Here are the x-intercepts, here's one here, and here's one here. So it's just this, x equals 1 and x equals 5, and that's your answers for the x-intercepts. What are the coordinates of the vertex? The vertex are this thing here. Vertex is this one here. And you can see just by looking at the graph, it goes across to x is 3, y is 4. So it's 3 and 4. That's where that came from. What is the y-intercept? There's only one y-intercept. It's this little lonely value here. It's where does the graph cut the y-axis. So it's y equals -5. Find the equation of the graph. So start by writing out the two x-intercepts and then putting them into brackets. There's a way, you might find something like in some of your topic assignments like this too. So our two x-intercepts are x equals 1, x equals 5. So I've kind of done that here. I'll just do it manually on the side as well, just to show you how I did it from scratch. X equals 5. When this was back into the brackety form, like, you know, but doing reverse solving, before it was solved, it would have been, I think what would have been x minus 1 when it was in a bracket would have been x minus 1, because x minus 1 equals 0, so x equals 1. X equals 5 in the brackets would have been x minus 5, because if x minus 5 equals 0, x equals 5. And then that technically could do as your equation for the graph. That might be fine. You might instead just want to do your foiling like I did here. Foil it out and you could give the answer like that as well. So if they want a fully expanded, simplified version, that would be fine. If not, that would be the equation of the graph. However, I just realised I should have, if I'm to write my final answer, I should write it as an equation, shouldn't I? Before, did I? Same with this one down below. So that one here, that version would be y equals x squared minus 6x plus 5. So make sure your final answer is an equation if they want an equation. Let's fix that one up. As the y-intercept is supposed to be -5 and not +5, we need to multiply every term by 1. Okay, yeah, so that's a very good point. Forgot that. So I hadn't answered the whole question. So I'll just undo that and just explain what I'm going on about here. Yep. So I thought these little ones that I circled before were the final answer. But if you look at the graph, the y-intercept shouldn't, according to the expanded version I've got here, the y-intercept would be +5. But on our graph, our y-intercept is -5. So use that as a double check. Maybe you needed to multiply everything by a number. Like if we got 5 in this little part here, and the y-intercept was meant to be 10, that tells me I should double every term. So I should multiply the entire thing by 2 to make it 2x squared minus 12x plus 10. But because it's not 10 in this case, it's -5. So to make it -5, we need to multiply every term by -1. So see what I did here? I just times -1 out the front, and then final answer, expand it all in, and you would get this answer here on the side. If you use the brackety version above, you could have also done that. So you could have also done -1 times the brackety version, see up here, x minus 1, x minus 1, x minus 5. That also technically is a correct answer as well. Just make sure you've got the negative out the front. See the negative there. That's where this one came from. -1. It's okay if you write -1 here, but you don't need the 1, so just put negative there. Both of those answers are correct. I'd say the most clearly and most overly simplified one is that one there, because you've done a bit of following as well. Okay, well, thank you very much for your patience with all that. And it's finally over.